have liters here. So I did 2.8, what was it, times 1,000 gave me 2,800 milliliters. And then I know that 1 milliliter equals 5 drops. So if I want to figure out how many drops are in 2,800, I would have to divide by 5. Does that make sense?
Mm-hmm.
So then I did 2,800 divided by 5, and that gave me 560 drops. But I'm still in per 2.5 hours, because this 2.8 liters will take 2.5 hours. And I'm still in, what am I? I'm still in the 2.5 hours. Does that make sense?
Yeah.
Because I haven't converted the hours. I've only converted the 2.8 liters into how many drops in total. Does that make sense?
Yeah.
Cool. So then I figured out how many drops, because they want it drops per minute. So I figured out how many minutes in 2.5 hours, which was 2.5 equals 150 minutes, I think it was. Let me check. 60 plus 60. Yeah. And then I divided 560 drops by 150 minutes to get my drop per minute. But then it gave me something weird. It gave me like 3.73.
I feel like that sounds good.
Drops per, but I don't know if it's supposed to be like a whole, like 4 drops per minute. Like, I don't know. But I can't think of any other way. So I've got my 2.8 liters. I found how many mils that was, divided it by 5 to get how many drops it was. Took my hours to minutes and divided the drops by my minutes to get. Okay, are you all good with that question?
Yeah.
Did you write it down?
Yeah.
Cool. Okay. Rihanna used her mobile phone while she's overseas for 1 month. The mobile phone plan has a base monthly cost of $60.
Would I go 35 times 110?
Yep.
Equals 3,850.
Oh, did you do, because it's
What?
35 cents. And so it would be 110 times 0.35, not 35.
Right, okay.
Is that all cool?
Yeah.
Yeah.
So $38.05.
Yep.
5 cents or 50 cents?
50.
Okay.
$38.
And then 0.25 times 1,500.
Yep.
$375.
Yep. And then what would you do next?
And then what? I just add it all up.
Yeah. And just remember this part here.
What?
She has a base monthly cost.
Oh,
of
yeah,
$60.
yeah.
Yeah. So $60 is fixed. And then plus the other stuff. And then pop it
Sorry,
in
I'm
the
using the
calculator.
calculator on my phone.
Oh no,
You
that's
can't see
fine. I guessed that was the case.
Did you get $473.50?
Yep.
Cool.
Good job. Okay. Have you been writing it all down so I don't have to?
Yeah.
Cool. I can
Yeah.
clear that. Okay.
Oh, this is hard. Oh my gosh, I don't know.
I hate these. Okay, let me get my...
I don't even know how to work that out.
I have a formula that I can give you.
Like,
Let me just find it. Here. So it's like this. Where is it? It's scale. I guess so. Scale equals... I don't know if this will work or not. Length on drawing over real length. Okay, let me see if this formula will work. Okay, what is the actual distance? So we want to find the real length. So, let's see.
are there questions like this in the HSE?
Maybe multiple choice or maybe at the start, but because this is, actually no, there might be, yeah.
Work.
Where did I do this? I did this, I don't know where it would be in your textbook. Let me have a look. Oh, did you hear that? That was a big bang. Okay, it would be in your rates and ratios topic.
Okay.
I don't know if you can see it. Where is it? Is it the top one? Yes. I don't know. Can you see it?
Yeah, kind of. A bit blurry.
Where would it be? It is scale drawings. There. You probably can't even see it, but it's fine. Okay. Do you look at the Cambridge textbook?
I don't have a textbook.
Oh.
But at school we use like the Oxford one, I think. It's like turquoise.
Okay. Yeah.
But like when I'm at tutoring, I use the Cambridge one.
Yeah.
So like.
Yeah. So it has a scale of that. 2 towns are 4 centimeters apart on the map. So I think the scale is saying that 1 centimeter equals 300,000 centimeters. So 1 centimeter equals, what is it? Would it be 3 kilometers, I think? And so you could do, wait. Okay. Let me try this. Ooh. Okay, so if you do, wait, are you there? I just can't see you.
Yeah.
You're still there? Okay, cool. So if we look at the formula, what is it? Scale equals length on drawing. I don't know why I'm rewriting it. Okay, let's just use the one there. So the scale, this is our scale here. Yeah.
Mm-hmm.
And so if I was to write that to put in my formula, because that's a scale, so it'd go there, I can write it as 1 over 300,000 is my
Mm-hmm.
scale, equals my length on my drawing. And what's the length on the drawing?
4 centimeters.
Yep. So I'd write 4 centimeters and would give me the real length, which is, or the actual length. Does that make sense? And so
Yeah.
then I could do 4 over 1 over 3. So if I put that into my calculator, it looks like that.
Mm-hmm.
And it would give me 12, what? A big ass number, that big. And then if I divide that by 100, divide by 1,000, it'd give me 12 kilometers. That's how many centimeters it equals 12 kilometers. So that's the actual distance between the two towns. So you can use that formula there if you want to. Does the formula make sense how I used it?
Yeah.
Cool. Or you can work out what I worked out in yellow, this part here. So what did I do? I did 1 centimeter equals 300,000 centimeters. So therefore 1 centimeter equals 3 kilometers. And if they're 4 centimeters apart on a map, I can just do 4 times 3 to give me 12 kilometers. So I don't know which way was easier. The formula would give you like a rule of thumb for every single scale question. Does that make sense?
Yeah.
Like for any scale question, you could use this formula and you'd be fine. Or you can just do it logically in your head.
Yeah.
If 1 centimeter equals 300,000 centimeters, 1 centimeter equals 3 kilometers. If they're 4 centimeters apart, I've got to times it by 3 kilometers. So 4 times 3 is 12 kilometers. I don't know which way is easier for you. Would it be the green or the yellow? The formula or just...
I feel like the green.
Okay, cool. Did you write down the formula?
Yeah.
Cool. And if they give you these two, like the length on the drawing and the real length, then you could figure out the scale and like vice versa. Yeah. Wait, do you know how I went from this to this?
Yeah, like
I went from the pink to the blue. Because, you know, like you want to get the real by itself.
how'd you put 4 over 1 over 300,000?
So if it's like, what if I just did 4 on 3 equals 2 next? If I wanted to get if I wanted to get X by myself, I'd take this one over and times, to be 4 on 3 times 2. Because if this is divide, you do the opposite, yeah? Does that make sense? And so I'm doing the same like logic theory, but instead of timesing across, I'm going to do the fraction. So if anything's ever, how do I say? If anything's ever like this, and I want to get the y by itself, you just take whatever's on top and you put it on top over there. So then it'd be 1 over x equals y. So that's like the method I use. And so I just took the 4 and I just put it on top of that fraction. And so when you put it in your calculator, you press the fraction button. Can you see that?
Mm-hmm.
And then you go to wherever. So I wanted the fraction on the bottom of that fraction. So then if you press down and then you press the fraction button again, you'll get a fraction on top of a fraction.
Oh, okay.
And so I put 4 in the top one, and then I put, 1 and then 300,000. And then equals, and it gives you 12,000. I know it's back to front for you, but that's how it worked. But does this thing up here make sense?
Yeah.
Cool. It's just like, you know, you do the opposite when you take over to the other side. Yeah, it's like I'm doing that. And I just did that in that pink formula. So I got that blue thing. And then you just pop it in the calculator. But then you just have to remember that the big 1,200,000 number is in centimeters. And they are spread in kilometers. And so you just divide 12,000, 100 million, whatever it was, by 100 to get meters, and then by 1,000 to get kilometers. And then I got 12. Okay. Cool. 2 cities. Oh no, I just deleted all my working out for this question. That's fine. Okay. 2 cities are 125 kilometers apart. How far apart are the 2 cities on the map? Let's see if the formula will work. Scale equals length on drawing. Drawing over real length. Okay, 2 cities are 125 kilometers apart. I'm just going to do it up here so I can see. How far apart are the cities on the map? Okay, so I know my scale is this much. And I need to figure out the length on the drawing. And I know they have a real length of 125.
Can I get a fraction on a phone?
I don't know.
Like on my calculator?
I have no idea.
If I turn it sideways.
Okay.
Oh, wow.
Can you?
Yeah, I still can. Wait.
Oh,
wait. Does it say error? Clearly doesn't work. Wait.
Oh, that's in... What? I'm actually going to I'm going to change that. Okay. Did you... Are you all good with this? How I got to there?
Right.
Yeah? I got my scale, which was this thing here. Wait, let's see if I can do it color-coded. I like color-coded. Yellow. So that was my scale, yeah?
Mm-hmm.
And
yeah,
then
that actually makes it a lot easier.
real length. And the real length that they gave me was 125 kilometers. But because my scale was in centimeters, I put my kilometers into centimeters to get them to the same measurement, I think. And then I needed to figure out what X is, and X was the length on the drawing in centimeters.
Right.
So because I had already turned the 125 kilometers into centimeters, and this was in centimeters, whatever my answer is will also be in centimeters. Does that make sense?
Yeah.
Cool. And so then you can just do 1 on 300,000 times by, ooh, that was close. Okay, equals. And then I got something like 41.6, 42 centimeters. Hopefully you can squish this all into this section down here. But I just wrote really big, so that's why it's over heaps of space. Okay. Question 24. Andrew, Brandon, and Cosmo. I think this was one of my HSC questions.
Really?
Let me check. Okay. You have a look and see if you can do it, and I'll check if it's one of my HSC questions. Otherwise, it was very similar. I don't know how I remember that. I have like the weirdest memory. Okay, Maths Standard 2019. Maths Standard 2. Okay. Awesome.
Oh my God, my mom.
Is this it? Andrew, Brandon, and Cosmo are the first 3 batters in the school's cricket team. Yay! No reason though. We can check if we get it right. It's the exact same. Okay, that's good. All right, let's do it.
I thought a ratio was just like the numbers next to each other, like with like
this?
column. Yeah.
Yeah, but they want it in the simplest form.
Right. So we have to think of something they can all go into.
Yeah.
5?
I think so. What, 6, 5, and 8? Let's see what the answers say. How great. Wait, is that what you wrote down?
Mm-hmm.
Cool. Okay, I can erase that so I don't have to. Actually, I can just go clear all. Okay. Oh, I'm still there. Okay, so I want the answers. Marking guidelines. Is this what we got? 6, 5, and 8?
Yeah.
Yes. Okay. In the same match, the ratio of the total number of scores by Andrew, Brandon, and Cosmo to the total number of scores run by the whole team was 1936.
I don't get it. Wait.
In the same match. Okay, so what was it? What were the things again? 6, 8, and what was it? 6, 8.
5, 6, 5, and 8.
5, 6, and 8. What does that equal? 5, 6, and 8.
Doesn't matter what order they go in.
Just keep the same to what was up here. So was it 6, 5, and 8?
Yeah.
Okay.
Sorry, I just didn't know because I was like,
No, that's fine. I don't think it really matters, actually. It does for the first question. I'm not sure about this one. So 6, 5, and 8. So that was what we got for Andrew, Brandon, and Cosmo, yeah? Ooh. And if you add them all together, 6 plus 5 plus 8, it equals 19. So what it's saying is that the total number of scores run by the whole team was 36, and out of the 36, Andrew, Brandon, and Cosmo scored 19 of them. Does that make sense?
Yeah.
So how many runs were scored by the whole team? Okay. Okay, well, we know in the first one, Andrew scored, 30? Oh, Andrew scored 30 runs, was it? Which was the ratio of 6. He obviously scored 25, I think. Was it 25?
Yep.
And then the other guy, 40. And so what does that equal? Or if you plus them all together. 30 plus 25 plus 40 equals 95. So we know that 19 and 36, and we have 95 plus a number. What could we do now? 95 divided by 19. Okay, and then you do this. 95 divided by 19 equals 5. So 36 times 5 equals 180. 180 runs by the whole team. Okay. Do you want me to explain how I got all of that?
Yeah.
Okay. So, wait. I don't know if you want to write it down, Nita, or whatever you want to do. I don't know.
No, it's okay.
Wait, let me just check the answers before I go explaining. Yes, we got it right. Woohoo! Okay. So we knew. Okay, so they said that. What just happened? Oh, why does this happen to me?
I feel like
Why do bad things happen to good people? Okay. Where did I go? Here. Okay, what question are we up to this time? Okay, we're back here. Okay, so we figured out the ratio of the runs in the first question, right?
Mm-hmm.
We got 6, 5, and 8. And so it says the ratio of the total number of scores run by Brandon, Cosmo, blah, 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 to the whole team. So it's getting those 3 people against the whole team, yeah?
Mm-hmm.
And so we could check that. We did 6 plus 5 plus 8 equals 19. And then their ratio there was 19. So we knew that Brandon, Andrew, and Cosmo added together was 19, yeah?
Yeah.
And then we wanted to figure out how many runs that was, not just what the ratio was. So that's what we did here in yellow. So this is actually how many runs it was. So although the ratio was 19, and so the ratio of 6, however many runs that was 30. And our ratio of 5, the actual number of runs that 5 was 25. Does that make sense?
Mm-hmm.
And so then we got a total of 95. And then in this, what is it called? That little box there in pink, I put it together. So we know that the ratio of 19 to 36, and we had the runs 95 to something. And so you wanted to figure out what the something was. Are you still following? Is it all good?
Yeah.
Cool. And so then to figure out what, like, the ratio between the two, between the actual ratio and the runs, we divided 95 by 19 and then we got 5. And so we know the difference between 19 and 95 was 5. So then if we times 36 by 5, it will give us 180, which was the runs by the whole team.
Right.
Is that all good?
Yeah.
And then did you write that all down?
Yeah.
Okay. And then if I show you the answers from the HSC paper, it was this. It might explain it better. The total number of runs scored by Andrew, Brandon, and Cosmo was 30 plus 25 plus 40, 95. And let X be the number of runs scored by the whole team. So that's what they did. Yeah. They did 19 and 36, which is what, like, rewrite down. And then they did 95. I had just written it down a bit differently. I wrote it down. What did I write it down like? I wrote it down like 19, 36, 95, question mark. That's how I wrote it down.
Right.
And then I divided 95 by 19 to get 5. And then 36 times 5 equals 180. That's what I did. What did they do? Okay, so they then put it into fractions and then times the fraction. That's smart. I would not have done that. If that's easier, I'll do that. Because you know that a ratio, when written like this, can just be a fraction. Like that.
Yeah.
Oh no, they did it the other way around. 36 or 19. So I don't know which way was easier. I don't know. You're given a ratio and however many runs the ratio equaled for the 19, and you just got to figure out how many runs it equaled for the 36. Is that all good, that question?
Yeah.
Cool. Okay, let's complete this table.
I did it. Do you want to do it, or do you want to just check mine? Or
I can just check
then...
yours.
Okay.
Let me see. Here we go.
Okay.
Wait, let me take a photo of that because
Okay.
I can't see the other thing. Okay. Cool. And then let me go back to Messenger and let me just quickly check. So between C and A was 2 yes. Between B and C was 2 yes. Between B and D, 6 yes. C and A, 2 yes. C and B, 2 yes. What else? A and D, there's nothing. Yep. And D and C, 3. Perfect. 26. Cool. So we're up to this one, yeah?
Yeah.
Awesome. Okay. Aiden, what weird names. Oh, by towns. Okay, that's fine. 6 towns. The next one shows the road connections and the distance between towns and commas. What is the shortest distance between Arnhem and Carey? What did you get for question A?
Probably to Dunlop and then
Yeah.
Farnham.
So 200.
Yes.
Awesome.
How many different ways are there to travel from passing through any town more than once? Oh my gosh, I hate these questions.
Without passing through any town more than once. Okay.
Okay, so 1 for the first way.
From Farnham to Carey. Okay.
Two,
There we go.
4. I got 4.
Oh, no, we can't go back there. I'm up to 5. Did you do the one I did in red? Go up to Dunlop, down to Enwyn, up to Bredon, up to Carrie?
Yeah, I did the one you did in red. Oh, I didn't do the one you did in green. Okay.
And then there might be another one. Dunlop, down to Enwyn, across to Arden, up to Bredon, up to Carrie. Okay, at the moment I'm up to 6, and I don't think there's any more. Okay, I think the answer is 6. Is that what you got?
Yeah.
All right. Are we cool with question B?
Mhm.
Cool. What's the next question? An engineer plans to inspect all of the roads in this network. He will start at Dunlop and inspect each road only once. At which town will the inspection finish? Okay, interesting question.
I feel, does it have to go to every dot or every number?
I think every number, because I think the lines where the numbers are, I think they are the roads between each place. Yeah.
Right.
And he's inspecting all of the roads. Oh no, what did I just press? Okay, let's go back. See ya. Okay. So we'll start at Dunlop and inspect each road only once. At which town will the inspection finish? Okay. How interesting. I think it would. Oh, that's annoying.
This is like impossible.
What? Can he go back to Dunlop?
I think he can, you know.
Oh, well then I just did it. Okay.
Should
Let's
we
see.
write Braden?
What did I just do though? I think I did 1 here, 2, 3, 4, 5. Did you say Braden? Is that what you said?
Yeah.
Yeah, I think so. Is that the only way to do it? I don't. Let me see. I think it is. Cool. Okay, and what's next? Network diagram below. Show the entrance to a wildlife park and 6 picnic areas in the park.
3.
In this graph, what is the degree of the vertex at the entrance to the wildlife park? Which one's the entrance? Oh, yes. I was like, which one's the entrance? It doesn't say. And then it's right there. Right there. Yes, 3. What is the shortest distance in meters from the entrance to the picnic area? P3.
Entrance P6, P3.
86. I mean, and what's that? 1200? Oh, I can go shorter.
Really?
Yeah.
Yeah.
Oh,
600.
Yeah. Go to P1. Because what's that? That's 1000 instead of 1200. Any others? So it'd be what?
I don't think so.
Cool. Entrance to P1 equals 1000. Okay. Should we do one more question?
Yeah, sure.
Okay.
Oh my God.
What question is that? 27. So I need to go to 28. Okay. How do I go there? What's wrong with my computer? Oh my goodness. I don't know what's wrong with it. Okay, let's just try again. Messenger. Okay. I'm on 18%, but I doubt it will die. But just in case. Okay, where do I have to go? I have to go down here. To Olivia. And what question did I say we were up to?
28.
28. Is it this one? Yes. Okay. Ruby, Amber, Charlie, and Taylor are 4 children playing a game. In this child's game, 7 posts are placed in the ground. The network below shows distances in meters between 7 posts. The aim of the game is to connect the posts with rhythm using the shortest. Oh no, we have to do Kruskal's algorithm. Do you know what Kruskal's algorithm is?
I think so, yeah.
Cool. Okay, I'm just gonna do it. Oh, why does my computer do this? Why does it keep doing it? Okay. It's hard to see the numbers. Wait, there's not even...
I got like a bow shaped.
There's not even any things. That's fine. Okay. Like there's no letters at the vertices, so that's totally fine. Okay, 2, 2, 2, 2, 2, 2, 3, 3, 4. Is this what you got?
The bow shape thing?
Kind of.
Oh, wait, I accidentally connected the 5 one.
I think that's fine. Because you want
No, that is
the minimum
right.
weights, right? Yeah.
Yeah.
4, 2, 2, 3, 3, 2. Yeah. Okay. Razor. Determine the length of this minimal spanning tree. 8, 10, 16.
Mm.
Oh. How many different minimal spanning trees can be drawn for this network? What? Okay, let's try again. Minimal span. What? Okay, this is 16.
That's so annoying.
I don't know what the question. 2. 3. I don't know what the question was. Oh wait. 2, 3, 2, 3, 2, 4. What's that? 8, 9, 10, 16. I think there's 2 ways. Yeah. Let me attempt my 2 ways. Are you having a look at how many ways there are as well?
Yeah, I just like.
Okay, there's that way. But I think there's also this way. I think that's the 2 ways, the yellow and the red. Because that's 2, 5, 6, 7, 8, 9, 10, 16. Because this one here, ooh, that one there is worth 3 and that one there is worth 3. So it doesn't matter. You could have done either of them and it would have been the same. Either the yellow or the red would equal 16, but if you did it anywhere else, it wouldn't have worked. So I think it's 2.
Yeah.
Does that make sense?
Yeah.
Cool. Because say we chose to do this line instead of the 4, that one's worth 5. And so that would give us 17 instead of 16. Yeah. Sweet. Okay, my computer's on 12%. That's fine. Okay. Well, should we leave it there?
Yeah.
And how many more questions have we got to go?
Literally 2.
2 questions?
Yeah.
Do you just want to get them done now?
It's literally up to you. I don't mind.
What, wait, it's just this one here?
Like you have to draw something.
About the America showgrounds. Let's just do it. I don't care if it goes over. I'm totally fine.
Okay.
I'm not doing anything else tonight. And then that's that done. And next lesson we can like work on your English or whatever. If you have something written by now. Is that cool with you?
Mm-hmm.
Awesome. Okay. At the Avoca Showgrounds, 11 locations require access to water. These locations are represented by vertices on the network diagram shown below. Okay, we just have to create a minimal spanning tree, right? I think. Oh, stop doing that. There we go. Where's my little thing? Okay, I'm gonna have to. Oh, I'm not sharing. I was like, why can't you see this? Okay, there we go. There we go. Okay. Okay. On the dash diagram. Okay. Let's attempt it. We want 40, 40, 40. What else? 50, 50, 50. We have to do that one. 60, Did you get something like that? Oh no, it's not connected yet. Dang it.
Wait, why isn't that connected?
Now it is. It wasn't before. I quickly fixed it. I don't know if there's any other ways. Let's have a look. 40. Oh, you have to do that one there. You have to do that one there. You have to do. What else is there? To connect this, you could do 50, 60, or 70. So obviously going to do 50. To connect these, you could do 70 or 50. So obviously going to do 50. I'm going to do 50. I think that is the only way. Is this what you got? Oh no.
Yeah.
Cool. Calculate the length, total length in meters of water pipe that is required. Did you add them up yet? That's totally fine. Let's do that. 60 plus 60 plus 40 plus 60 plus 40 plus 50 plus 50 plus 50 plus 40 plus 60. Do you get like 510?
Yeah, I did.
Awesome. I think that's it.